All right. So, for those of you who it's your first time here, welcome to Learn Teach Code. I'm Beej. Today we're going to cover MariaDB, which is effectively the same as MySQL. MySQL is a very, very popular open source database. If you're not familiar with open source, it basically means that the code that makes the database is openly available for anyone to use, copy, edit, all that sort of stuff. And therefore, it's often free. Okay, so there's a free database system that you can set up and use. If you are not familiar with databases, actually, let's start with that. So what's a database? Does anyone have a guess as to what a database is? A very high-level definition. A bunch of data? A collection of data? Yep, both accurate. If you've used Excel, you have technically used a database. You'll actually find that databases are really similar to Excel spreadsheets. We use a structure called a table, which we'll cover in a couple minutes. And it's very, very similar to a spreadsheet, but much more powerful because you can do all sorts of aggregations and filtering, in my opinion, much more easily than a spreadsheet. But we'll get to that in a bit. So databases, they're often used for web applications. Well, they're used for most things. Now, there's all different kinds of databases, but today we'll be focusing just on relational databases, which are the most popular right now. There's other things like Mongo and Hadoop and all those sorts of things that you've probably heard of. Those are a different kind of database. They work differently than what we're covering today. Okay, so don't get confused. Other databases that are similar to what we're using today. Today we're doing MariaDB. It's similar to MySQL. There's also Postgres is similar, or PostgreSQL. Microsoft SQL is also similar. And Oracle has some similarities. I've never actually used Oracle, but it's the same category of system. So today we're going to cover three major areas. We're going to do installation and configuration. Okay, so getting the database installed and setting it up. Then we're going to cover how to design a database, how to make tables, and how to set things up so that when you want to use your data, it's a reasonable way of doing so. And then we're actually going to work on manipulating the data itself, inserting data, pulling out data, changing data, all these sorts of things. By the end of it, we'll have a tiny little Python application. Where you can see how to use normal programming languages like Python or Java or whatever to actually pull data from a database. Do we have a spot up here? Yeah, we have a seat up here if you want. All right, so if you haven't already downloaded the installer, go ahead and do that. Let's go ahead and run through installation. It should be pretty simple. I've never actually installed it on Windows. I've only ever installed it on Linux, so hopefully we don't run into any hiccups. But for Windows, you're just going to run through the installer. If you're on Mac, I sent links for instructions in the chat. I forgot my work computer, so I can't actually walk through it with you today. I apologize. But pretty much just accept terms, install. All of the defaults are usually OK. You probably don't need this Heidi SQL. Yeah, you don't really need that. We're not going to cover visual stuff. We're just going to do command line today. And you can just click next. This is really important. So, most times, for security purposes, all right, your root user should have a very, very strong password. A strong password is long. It doesn't have to be super complex. It has to be long, okay? Because the likelihood of a person guessing your password is pretty slim. The likelihood of a computer brute forcing your password by just making guesses and guesses and guesses is much more likely. So longer passwords make brute force harder. Beyond 16 or so characters, it's effectively impossible. Not impossible, but it takes an outrageously long time. So come up with a long password. I'm just going to do icon database. Huh. This is going to be a database that we are installing on our computers. Yeah. For now, you can make it whatever you want, because it's not like we're going to be launching an application with the database running on our laptops. but just, for general when you go to the real world, that sort of stuff. So, normally you would never want to click this button, ever. Enable root. So root, when it comes to database systems and Linux systems, root is the super user. Root can do anything, which is terrifying. So usually you want to lock down root. Only allow root to connect from the local machine. Okay, so you have to be logged into the machine and then access the database. And root should have a very, very strong password. And don't allow access from remote machines. Okay, but because I foresee us having trouble getting the database set up, when we start doing queries and stuff, you can all just connect to my database if you need to, if you can't get your local one set up, because we are going to be moving pretty quickly. And then we are going to use UTF-8. All the defaults are here. Brief networking thing. So on computers, when you connect to a computer over the internet, you can think of a computer like a house. The house has an address. It's an IP address, as you've seen, or often a DNS entry like google.com. And a house has doors, right? Doors that you can enter through. On computers, these doors, or the metaphor I use is a door is a port. A port is just a number. You can think of it like a label for a door. Okay? Now, each application needs its own port. Okay? You can't have... a door can only fit one person waiting to open it. Right? It can't fit like 50 people. So the default port, the default door that other things can connect to for MySQL is 3306. That's the default. Very useful to remember. The default settings are fine for the rest. Since this is only a basic class, we're not going to get into what that means. What's up? Yeah. I imagine you will probably want Korean characters in your database. So, you can do this if you want. Actually, yeah, I'll do that. And then you can install. Should not take too long. And then, so that's if you're on Linux or if you're on Mac, it's actually much easier. You can just use your package manager for Mac, Brew. For Linux, Yum or apt-get, depending on which Linux version you're using. And you can just say install MariaDB, and it just works. Because all of these settings that we did are actually stored in a file, which we will show in a second. So now we have a database. If you're on Windows, man, am I not going to be able to... What am I doing? Oh, Windows, you're drunk. Come on. Of course. Uh-oh. Okay, there we go. Uh-oh. My computer's tripping out. Okay. So on Windows, let me just check this before I... Yeah, okay. So if you're on Windows, your database is already running. Okay? In order to get it, you need to access your services. So if you just hit the Windows key and type in services, you'll get a window that looks like this. Of course, resize is weird on my machine. And then it will show up as MySQL, because MariaDB and MySQL are basically the same. Okay? Now, on Windows, you probably, since you don't want a database running on your laptop all the time, you probably want to set this to not automatic. You probably want to set it to manual. Otherwise, it's going to make your computer... It has the potential to make your computer a little slow. Okay? And again, if you're on Windows, it's automatically running. If you are on Mac, I believe it's also already running. I'm not 100% sure. Okay? So, at that point, you want to open up command line. Does everyone know how to open command line on their machine? Does anyone not know how to open command line on their machine? Yes, CMD. So open up CMD, and then you should be able to do... This is tiny, isn't it? Hold up. Let me make this bigger for you. 28 should be good. Beautiful. Yeah, okay. So what you should be able to do is, if you type in MySQL -u root, okay? -u is the user we are logging in as. Right now, there's only a root user, okay? And then -p, because we need to enter a password, if you set a password. And then because we're just connecting to the database on this machine, you can just hit enter. Then enter your password, and voila. If you're on Mac, you won't actually see the characters show up. That's a security thing. It is working, I promise. It was just installing. It was just running the installer, and then opening command prompt and running this command. There isn't really a step before it. It's not working. Oh, really? Oh, boy. You see, this is what's difficult when you do this stuff for a living, and then you're teaching it on a machine that you use for normal work. Because you're like, oh, it must do that for you. Oh, no, I had it set up already. Give me just a second. Yeah. You may have to set path. If you're on Windows, you want to go to Program Files and MariaDB and this bin folder, and you want to add it to your path. And you can, if you look up system properties and environment variables, you look for path down here, you edit it, and then you can just do new and then paste the location. Okay? All I did was go to the MariaDB installation directory. And I went to bin, and I clicked here, copy, new, paste, and then we're good. I don't actually want to use this one, so I'm going to remove it, but that is what you want to do. Okay. Yeah, sorry. Going too fast because I want to get to the... so you look up system properties. Okay. Oh, or you can look up environment variables. So if you type environment variables, on your start menu, you'll get this, edit system properties. And then down here at the bottom, you want to click environment variables. It doesn't really matter. I usually do system. But if you're the only user on your computer, it doesn't matter. Then you click environment variables. And then in this bottom side, you look for path. Where is it? Path. And then edit. New. And then paste the location. You have to reopen the command prompt for the path change. What's that? Yep. So in the start menu, which I can't show you because it's on the, you know what? Let me just. It's working? Good. Yep. I'll go through the whole thing in just a second. All right. So down here, you hit your Windows key and you do environment variables, right? Edit the system environment variables, and this window will pop up. Okay. From here, you click environment variables. Also, this is why Windows is a pain. On the bottom side, you scroll down till you see path. And then you click edit. Okay. You can pause here. Open up your Windows Explorer. Go to your C drive. And go to Program Files. From there, look for MariaDB. And then the bin folder. Okay. Click in the bar up top. Copy that. Hit new and paste. Okay. Yeah, we should be okay on time. Good? MariaDB. Yep. And then copy that, paste, and you should be good. Are you Mac guys okay? Cool. Oh, okay. So that means it's just set without a password. We'll cover how to change that in a second. Okay, is everyone good? So once you've made that change, you need to close your command prompt, and you need to reopen it. And then MySQL will be available. Okay? Holy crap, that's a lot of help.
Wait, for the path, it's a semicolon, and then you paste it?
Yes. Yeah, okay. All right, let me help you out, James. Is the server running? Go to services. Just type in services. Oh, that's a different services. Type services in green. Scroll down, look for MySQL. Is it running? Okay. So now down here, do MySQL. Hit enter.
Did you use the homebrew?
Maybe
Did you use the homebrew?
Yeah, I don't think you got the top going correctly. Which, let me see your path.
Because earlier I stole it. I just did use the homebrew and then everything went fine.
I will search already.
Oh.
Some versions
Oh, wait.
cannot be accessed through the directory.
Oh, it's already installed. Did you set a password? Oh, jeez. When did you install it? Just now? And you did not set a password? Did you use brew to install it?
Yes.
Okay. Give me just a second.
So I either, right?
So I sent a link in Slack on how to fix it. You want to do MySQL D. Unknown option initialize. Oh, really? Not helpful. There we go. Still not helpful. These are just configuring. Oh, here we go. That sucks. Okay, for now, don't worry about the server. After class, we can work on fixing the server. Just connect to mine for now. If you're having trouble getting the server installed, we cannot spend too much time getting that fixed. So you can just connect to mine. If I could learn how to type. And let's see, that is what we want, so I'm going to write that up there. What you want to do is 192.168 and 183. You can do, so I showed you the U root and the P flags. There's also an H flag. If you do -H and then you give an address, you can connect to a remote server. So if you want to connect to my database instead of working on your local one, or if your local one is not working, you can do that. The password I set was ICANN database. Which is actually a terrible password. You don't want passwords to be sentences, but and there you go. Are you able to connect with that? Well, where did it go? Yeah, there we go. Huh? You're good. All right. So, congratulations, you have done your first database connection. Woo! All right. Now, what can we do with this? Generally, the first thing you want to do is create a user, because you don't want your application to do root things. You want to make sure that your application, whether it's like a website or whatever, can only do what it needs to do, right? So if your application, all it does is insert and select, basically add and read data, you only want to allow it to do that. You don't want to allow it to do things like drop your entire database, to just delete everything. That would be bad. So for security purposes, you limit privileges as much as you can. So what I recommend doing, whoa, what is going on here? One second, let me, my thing is all sorts of messed up. Okay, let's also do this so that we don't have people staring at the bottom of my screen. Cool. All right. So you can do create user. And then a username is composed of two parts: the user's name and where the user is connecting from. Okay, that can be very important. If you allow them to connect from anywhere, that can be okay as long as you're aware of what you're doing. Somewhere else, you should probably have a firewall only allowing connections from specific places. Otherwise, if you know the host that's going to be connecting to your database, you want to do that. So I'm going to call it, I'm going to call my user class, and it's going to connect from localhost, which is your local computer. Okay? And then you can do identified by to set the password. and I'm going to set it to horse battery staple. You can set it to whatever you want. Except I said the same word twice. But
That's the user password?
that is the user's password. Correct. Horse battery staple correct. Because that is nonsense. Also xkcd. But yeah. So once you've done that, make sure you add a semicolon at the end. In MySQL or in most SQL systems, you must end statements with semicolons. And there you go. So now, if I were to disconnect and connect again as class with a password with horse battery staple correct, I can connect. Okay, let me, come on. Okay, again, -u, and then the word is the user's name. -p says I want to enter a password. Okay. Now, actually, people are still typing, so I'm going to wait a second. Going to be a little tight on time, but that's okay. Did you set a password? Let me see what you're talking about. One of the difficult things teaching things that you work in every day is that you forget what people don't know. Before you do like MySQL U class P, you'll notice that here it says MySQL arrow, right? That means we are working inside the MySQL system. So to do a connection to MySQL from within MySQL doesn't make sense. So first I have to log out of MySQL by typing in quit and hitting enter. Now you'll see that instead of being MySQL arrow, it's where I am on my computer arrow. And then I can log back into MySQL as the other user. Okay. What did your... Can you scroll up and show me what your create user statement looked like? Create user... Oh, you have an error in your MySQL syntax.
This is, I think it was, it's here.
Yeah, you never got the user created. Create user class at localhost identified by password. When did that work? Log back in as root. Yeah.
How do I get out of this dash arrow?
\C. Or if you just semicolon enter, it will terminate the statement. It'll be an error, but whatever. Okay. Did you get your user created? So if you got access denied, it either means that you entered your password wrong, or the user was not actually created. If you scroll up and look at your here, let me show you what that would look like if I made a mistake. So if I did create user something at something identified by bogus, right? And let's say I actually misspelled by. Okay. Oh, hey, I actually missed a quote, so that's even better. You'll see this big giant word error. Okay. So make sure.
Mine says the queries are okay and 0 rows are affected.
Okay.
And then I literally just typed in the same password.
Okay. So at this point, you know how to create a user. Let's pause on the SQL stuff for a second, and let's do configuration. And then we'll come back to SQL stuff. Okay? So if you go to wherever MariaDB was installed. Oh, are you going to make a liar out of me? Of course you are. Nope, there it is. INI, really? Yep, okay. So if you're on Windows, go to the MariaDB installation directory, and I'll cover Mac in just a second. Go to the MariaDB installation directory and go to Data, and then go to my.ini. If you open up this file with a text editor, you could use Notepad or whatever, you'll find a file that looks like this. Huh? Kind of, yeah. These are the configuration settings for the MySQL server, for the MariaDB server. The data directory. When you're creating an actual database on an actual server somewhere, this is very important. Because usually a systems administrator, they'll have like your home directory, like your user directories, on a very small disk. And then they'll have some other directory, usually var data, on a very, 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 very large disk. And you want to make sure that your MySQL server is pointing to that very, very, very large disk. So remember this data dir thing. We're not really going to use it here because we don't have all sorts of crazy partitions on our own laptops. But make sure that on an actual server, when you are installing MySQL, make sure the data directory is in the correct place. Otherwise, like a few days into launching your product, your database is going to choke because it ran out of disk space. And you're going to be like, what the hell? And then you'll have to shut down the database, move all the files, change the configuration, restart the database, which actually isn't so bad, but it's downtime for your application. And you want to avoid that. Okay. You can also set the port, like I mentioned before. The default port is 3306. And there's a couple of other settings, but they are not what we are going to cover today. If you look up my.cnf, which we'll show on the Mac in just a second, you'll see all of the different configurations, and there's a lot of them. Most of the defaults are okay for doing development. For doing a live, we'll want to do some research before doing all of this. Okay, this is only a beginner class. So, if you are on Mac, fortunately I have a Linux machine here, which is close enough. Oh, maybe that's too big. Okay. You want to open up a file at /my.cnf. Can you see that? Is that still too small? Is that better? Cool. And then I'm using Vim. You can use TextEdit, whatever. Whoa, that's huge. Okay. And you'll see, again, data directory, and the default port is, you actually don't want to edit this file. Okay, this is just for reference. If you look at my.cnf.d, okay, usually on Unix-based systems, if there's a configuration file, there's also a .d folder. And that's for all of your different applications. So if you had several different configurations, you would want to put them here. Whereas my.cnf is considered like the core default settings. So you could see server.cnf, and here's a whole bunch of other settings which are actually empty, but you get the idea. Okay. Questions from the Mac people, or are you guys okay? Cool. For Windows? It should be, if you went with the default settings, it should be C, program files, MariaDB, and then data. You'll find the my.ini.
Oh, my.
Yeah. Okay. So we could change the port if we wanted to. And for security purposes, it can be a good idea to do that.
So this is the configure file.
Correct. This is the configuration file for the server.
Now this is just for the server, right? This is how the server behaves. This has nothing to do with the data in the server. Just how the server works, like how much memory it uses, how it does paging, the index strategy, well, not the index strategy, those sorts of things. Okay? Questions about configuration?
Can I see the line of create user?
Sure. Let me clear everything out real quick. Create user, my username at localhost, identified by some password. Okay. Let me put this in Slack, because that was terrible. Because that's why we have Slack. There. Hopefully that's a little easier for you. Okay. So let's take a pause again from working directly with the database, and let's go with a little bit of theory about how databases work and how you would want to design a database. Okay. The example we will use, and that is often used by all sorts of tutorials, is kind of an HR system, right? You have you have a company, you have like managers, you have employees, you have organizations, all these sorts of things, and all of these different, we call them entities, right? All these different things have relationships to each other, and that is why we use database systems like MySQL, Postgres, although these are all relational databases. Okay, so the way data is stored. Make sure that the recording is able to see this. Oh, that's awesome. No, when I changed the monitor, well, that sucks.
It just recorded you?
No. It was looking for the external monitor, but when I set them to use the same monitor, yeah. Sorry, folks in the recording. Basically, this is how to create a user. And then hopefully via the audio you can figure out the rest. I'm sorry, don't hate me. But I do want to make sure you can see the board. Okay, so we should do... Nope. I can't even brain. Video capture device. That is the thing we want. We want this one. Yes, because we know that works. Beautiful. My goddamn... What's up? Okay, cool. So, where... Alright. So, yes, databases. So, I mentioned earlier that Excel is just like a database. And what I mean is, a database just stores data in what's called a table. Okay? It just consists of rows and columns. All right? Very, very simple. Now, the excellent part is this is easy to understand. Okay? It's also very easy to kind of collapse and expand your table in all sorts of ways. Now, we have a little bit of terminology here. These are obviously columns, right? But we also call them fields. Writing is hard. These are also called fields, and then we have rows, which are also called records. Okay, so if you hear someone say record, they mean a row. If you hear someone say a field, they mean a column. Okay, a little bit of vocabulary. And databases are just sets of tables, where one table is one entity. So this could be like an employee table. Right? Now, your fields must be defined beforehand. Okay? So design is very, very, very important. You must take time to design. Otherwise you're going to hate yourself later. Okay? So these are your, well, they're your fields. So usually you want to have an identifier for each row. Each row should have a unique number, or string, depending, that identifies that row. All right. There's a whole bunch of crazy reasons for that, which we'll cover in a little bit once we get to querying, but for now, just accept that as true. Okay? So normally you'll call this ID, or you might call it employee ID. Either one is okay. It's usually whatever your company prefers to do. Okay? And then you could have other things like name, and then you could have what's something unique to, let's do phone number. Right? And then a row would be like, okay, Beach 555, right? Or 2 James 777 because he's lucky. You know, so on and so forth. So each time, now when we design this table, you're probably thinking, oh, I have to keep track of like every number of each user. You don't. Okay, you can set things up so that it will do that for you. We'll cover that once we actually write the code to do this. Okay. So that's kind of the structure of data in a database. Now they're at a high level. There's a whole bunch under the hood, but this is the basics. So now, so this is cool. I have a whole bunch of employees, right? But maybe I want to say that these employees are in an organization. And maybe this this organization, it also has an ID, and then maybe it has a name, and then maybe it has a manager. Okay? Now, how do we get these two things to know about each other? I did not give myself enough space. Oh well. In our, so when we have these relationships, we need to define what kind of relationship is it. There's 3 kinds of relationships. There's one-to-one, where it's one entity relates to exactly one other entity. There's a one-to-many, which is also many-to-one, just in the opposite direction. So in this way it might be one-to-many, and that way it might be many-to-one, same thing. And then there's many-to-many. We'll cover many-to-many in a second. But this strategy is for these two. Okay? So we have many employees belong to one organization in this particular company. Okay? We'll cover many-to-many in a minute. So the way that you create that relationship between the two entities is on the entity that has the many, right? We have many employees to one organization. You add a field. Okay? In this case, it's going to be org ID. Okay? And if we have like 1 is dev, 2 is HR, 3 is finance, whatever. Right? In this case, Beej would be in dev, James would be in dev, and then Bob. Bob.
That's the hardest part.
He's 666, so he's HR. So now, by doing this, we have established that we have 2 employees in one organization. Again, many to one, or many to one, whichever direction. Okay?
You get one common field.
Yes. Does that make sense so far? Cool. Believe it or not, this actually trips people up a lot. And in a bit, we'll go through a couple of examples that'll make you kind of go, wait, what? So that's that. Now, you're thinking, okay, cool, logically this makes sense, but like, how do I use this in a database? They're 2 separate tables, right? Well, when we actually write our database queries, a query is basically an interaction with a database. When we write our queries, we can actually take data from 2 tables and join them together. So we can take a record from here and a record from here and put them together to make one bigger record. Okay? So that's how that will work in the end. We'll cover exactly how that works later. So again, many to one. Cool. Any questions about that? We're good? Cool. All right. So now let's say this is a startup now. Startups, you don't have enough people, right? And so one person may have like 2, 3, 4, 7 roles, right? So in this case, a many to one isn't going to cut it. So we need a many-to-many relationship. Many employees can be in many relationships, or many relationships, in many organizations. We're talking about relationships. Okay, so in that case, this does not get an organization ID. Okay? You don't do that. Instead, you need to add a third table. Okay, this is called a linking table. And you could call it like, often what I do is LK employee, except I can't, whatever. Organization. I'm not a native English speaker at all. And then you would have your employee ID and your organization ID. And in this case, we could say James is in dev and James is in finance. And there you go. And Beej is also in dev. But I'm not getting anywhere near finance. You're on your own. What's up?
Why wouldn't you create a field in the first table with like or 1 or 2 or 3?
Because then I'm limited in the number of organizations that the employee can be in based on how many columns I make. So if I make only org 1, org 2, org 3, hey. Hey Bernard, can I steal you for a second and have you, actually wait, is there anyone? Crap, everyone is actually taking the class.
I could actually.
Okay.
I could watch.
No, I need chairs.
Yeah, I'll be on the side.
Huh? Oh, and there's more chairs? Okay. All right.
Somebody can sit over here. Yeah,
I can't wait till we move to the new place.
Oh, you can.
We're doing okay. All right. So this is by doing this system, I can have as many employees in as many organizations as I want. There's no limitation. Okay? Does that answer your question?
Yeah.
Does that make sense to everyone else? What's up?
You need a unique ID on the linking table?
Good question. The short answer is it depends. The long answer is, or what it depends on, is how are you connecting to your database, right? If you're writing raw queries, no problem, right? This is fine. If you're using some sort of object relational management system, like Spring Boot or Django or whatever, you might want a... Actually, no, Spring supports it. You might want an ID. So you could do... you could also add an ID if you wanted to. It doesn't really hurt. Like, the amount of data that this is pretty small. So you're not going to, like, kill your database by adding new data. So you could. It depends. Generally, I avoid it because I like things to be as simple as I can make them. But there's no harm in it. So, sorry that I don't have a super solid answer for you, but it really just depends on the circumstances. Does that kind of answer your question, or?
Why would it break on the ones that don't support it?
Say again?
Why would it break on the ones that don't support it? You mentioned like Django doesn't work, so why would it break?
Django might... I don't actually have enough Django experience, I was just citing ORMs. So some ORM systems, especially the younger ones, so what we have here is... I was planning on getting into that later, but I guess we're getting to it now. So each table must have what's called a primary key, a unique value that identifies each record, right? Like I mentioned before, this ID. The reason is that actually on the system, data is not stored like a table, right? Actually on the disk, it's not stored like a table at all. It's represented as a table to us because it's easier for us to understand. So it uses this ID to take all of the data in a record and relate it back to this. And this gets thrown around everywhere in order for the database to find data quickly. That's why these databases are so fast. Because for each set of data, it has a unique identifier. Now, in a linking table, if you don't have an ID like this, what you have is a composite primary key, where the primary key is not just one field, it's two. Composite means many things put together. Okay? So by having some ORMs don't support composite primary keys. Okay? Some systems just don't like that. In that case, you can just add an ID and set that as your primary key, and then you can add an index here. We're going to cover indexes towards the end of the class. Okay? Does that answer your question?
Yes.
Does it actually answer your question?
No. But we'll continue.
Okay. Basically, if the system you're using supports composite primary keys, just use these. It makes life easier. If you're working with your system and you're like, oh, let me define a composite primary. Oh, shit. Then add an ID. No problem. Take you 5 minutes. Okay? Is that a better answer? Cool. Any other questions before we continue? You look really confused. Are you okay? Okay. So how does this actually work? Because I did kind of gloss over it. Basically, when you say, I want an employee, I want all employees in the dev organization. Okay? You'd actually start with the dev organization because that's what you're filtering on. Okay? And then you can say, cool, let me find all records in this linking table that have org ID of 1. And you're going to go through here and you're going to be like, okay, this one, so I'm going to grab it. This one, I'm going to grab that. Now, let me go find the employee for that ID, and then it puts it all together. Okay? This will make a little more sense when we get into the querying. Any questions about many-to-many relationships?
Yeah, I just want to clarify. You mentioned that the ID there is actually needed, but if we're going to be using the many-to-many relationship, like if you're going to do a query for the organization one, I mean, it's like the unique identifier already for the employee, LK employee table, isn't it?
These two together
Yeah.
would be a unique identifier already.
So if you're going to add additional ID field there, will it be useful? In what ways can it be useful?
It's only useful if you're using an ORM that doesn't support composite keys, which should be very rare. Most ORMs support composite keys, except for Golang's Bigo, which I hate, but I love, but I hate. It doesn't actually support composite ORM or keys. Any other questions about many-to-many? Good. Cool. All right. So now that when you are designing your application, let's switch back to. Yes. When you are designing your application, you want to take the time to figure out what entities you have. All right. You want to figure out which columns they have or which fields they have, and then you need to figure out how they relate to each other. There's a strategy called when you figure out which entities to split up. That's a process called normalization. Okay, so if you need to look up more on the theory, that's the key word you want to look for. You want to look for database normalization. Good rule of thumb is if data repeats a lot, you probably want to pull that repeating data into a separate table and make relationships between them. Because what we could do is, in this employee table, we could just have dev, right? Or dev, finance, HR, right? But then that data would be repeated a lot, right? And that can actually slow your database down a little bit. By just having the number, it's a lot faster. Numbers are smaller than words, okay? So again, if you have repeating, generally you want to pull it out. There are exceptions. The saying is normalize until it hurts. Basically separate all of your data until it's really, really, really difficult to figure out how to separate it more. And then denormalize, put things back together until it works. Because sometimes normalizing things can actually break things or make them outrageously difficult. Okay? So now let's actually build this system. let's go back to your command line, and we're going to write some. Another distinction. When we're working with databases, there's actually two languages that we're working with. You have DDL, which is data definition language, okay, and that defines things like tables, users, privileges, all that sort of stuff, and that's usually going to be unique to a database. Okay, different databases will have slightly different DDL. Okay, and then you have SQL, structured query language, which is what you use to pull data out, to insert data, to change data. That's going to be mostly consistent across the different database systems. Some will have extra functions that others don't, but the core SQL will remain the same. Okay, right now we're going to do some DDL because we're going to define the data for a table. Okay, we're going to define one of these. So the way this works, let me actually, I don't actually like to do DDL within the command line because there's a lot of possibility for mistakes, and you have to type everything again in this giant pain. So what I prefer to do is grab some sort of text editor. Personally, I prefer Atom, but you can use Sublime Text, Notepad++, whatever. And make sure to set your text editor to SQL because it'll also recognize DDL. Oh, maybe it won't. There we go. So to create a table, you do something like this. And then, honestly, you don't really need to memorize this. You just need to kind of be familiar. You can look up a reference and be like, oh yeah, that's how it works. So I'm actually going to do that because I've been doing databases for 8 or 9 years, and I still haven't memorized this stuff because it's not important. So you can do something like ID int primary key. Now, so this right here says we're creating a table, and then this right here is the table name. Okay. Then we have to do parentheses, and then we define each field. Okay. First, we do the name of the field, and then we do the data type. Okay, the database needs to know what type of data is being stored. Is it an integer? Is it a floating point number, which is a decimal, basically? Is it text? Is it binary data? Is it just a 1 or a 0, right? It needs to know these things. And then in this case, we're telling it this is the primary key. This is the unique value for every single record. And then you also want to add auto-incrementing. Actually, do I do that before? Or? I don't remember. We're going to have to look that up in a minute because it's probably not going to work. But auto-incrementing will mean that when we put data into this table, if we do not set the ID, the database will look at the last ID, increment it or add to it by 1, and then just do that for you. Okay? Auto increment, auto step up. Okay? So makes your life easier. You generally want to do an integer auto incrementing primary key. And then we can do name, which is a variable length character. Okay? It is a set of characters, a set of text that can change length. Okay? And then you want to give it some length, right? So 255 is very common, but that's very long. If it's only a name, you can probably get away with either 32 or 64. People like to do powers of 2. It's not a requirement. So let's just do 32 for now. And then each column must be separated with a comma. Okay. And then let's do phone number. Now here's a tricky thing, right? A phone number is a number, right? But you might want to store it as a string, because do you ever need to do any math on a phone number? No, it's just a number. So usually you'll do a variable length character, and then you'll go, okay, let's see, we're going to do plus, and then 2 digits for the country code, and then a space, and you count however many out. I'm not going to bother counting for now. I'm going to assume it's 16. I don't know if that's right. Doesn't matter. Okay, just an example. Okay. So now at this point, I think this is all we need. Let's find out. I'm pretty sure I have a mistake here, but let's check it out. So then you can paste that. Don't forget to add a semicolon. Whoops, really important thing. I am so sorry, I forgot something. I was so excited to get into writing tables that I forgot to actually make a database. So what we have here is a database server. Okay? A database server can actually house multiple databases. Okay? They're also called schemas. So if you hear database and you hear schema, they're mostly the same thing. So what we can do, that's very easy. You just do create database and then the name. There are options, but most of the time you don't need to change them. On MariaDB, the character set is defaulting. Actually, wait, is it? I don't remember. I think the default character set is UTF-8, which means it will support Korean characters just fine. You want to let's double check that. Oh, no, I'm completely wrong. The default character set is Latin 1. Well, screw that. Okay. So you can do, let's call it database class, DB class, char set. I don't remember how to do this. That's for the whole database. Actually, yeah, if you set it at the database level, it should inherit it as UTF-8. However, there we go. Okay, so in this case, we're going to create a database called DB class. Actually, I don't think we need, yeah, you don't need the quotes. Yeah, so now we have our DB class database. If you type show databases and semicolon enter, it will show you the databases. Oh, I apparently had a database in here already. Oh well. So you'll see that DB class database that we just made. Information schema, MySQL, and performance schema are automatically added, so you don't really need to worry about those. Those are useful for the database to manage itself. If you want to do really crazy stuff, you can mess with those, but I would recommend avoiding it unless you're very comfortable with risk. Yeah, you do need to be the root user, because we have not. I'm going to cover permissions once we get the table set up. Okay. So now that we've made that database, we can say use DB class, and now we're in the DB class database. Okay? Because each table needs to be inside a database. Okay? So now we can take our table definition, toss that in there. Let me actually paste this into Slack as well.
Is there a reason you put the commas before?
Yes, you do need. Good question. So, yeah. So I like to put my commas before column definitions, because then if I need to move a column around, I don't need to edit the previous. Yeah. Whereas if I had my commas at the end, right, and I wanted to remove this row, then I have to edit this one too, or yeah. Basically, I'm just lazy, so I do it that way. But laziness can be good. Okay. So now that we're using the database we create the table, hit enter, and yep, I have an error. Okay. So let's look up MySQL auto incrementing key, auto increment primary key, because I can never remember what it looks like. Oh, it's just it's auto increment underscore No incrementing. There we go. That's what we want. So let me actually edit this. Much better. Whoop. And let's add our semicolon. There we go. Okay. So now you paste that in there. Ta-da. Okay. So cool. We have a table. Awesome. Let's go ahead and make the other tables real quick. Let's do the organization table. Oops. What's up? Oh yeah, dude. It's awesome.
I thought it would be cool if it start over and stuff, like it keeps going.
No, it keeps going. It's not that fancy yet. Hopefully they add that, because that would be cool.
Can you switch to the database?
Sorry? Oh, use and then the database name. Blah, blah, blah. Oh, I should tell you guys about that. So another thing that's worth noting, there is this value not null. Okay, so the database will allow you to enforce consistency. Okay, and you can say, hey, I don't want to store data unless I have these columns. If these columns are missing, don't allow the data to be stored. You can do that with this not null text. So I can say, oh, hey, the name has to be not null and the manager ID has to be not null. Okay? You could have done that with name and phone too, but I'm not going to worry about it for now. Okay? And then, if the application tries to insert data with either of those values as null, it will break. It will get an error. Okay? So that's a good way to enforce the integrity of your data. Now, the linking table, remember earlier, the linking table has a relationship to these two other tables. Okay? So there's two things we need to do. One, we need to define the primary key as composite. Basically that there's two fields for the primary key. And then we also need to tell the database that, hey, this table relies on two other tables. Okay? And that's called a foreign key. Okay? Because there's a key in another table that we're referencing. Since it's another table, it's foreign, so foreign key. Okay? I never remember the syntax for that, so holy crap, I can't type, but Google is smart. So there you go. Basically, after your column definitions, you just do primary key and then the column names. Okay, let me actually get rid of employee since we already added that and people in the back are kind of stretching. Okay, so that's how we define a composite primary key. And then for a foreign key, don't entirely remember, but give me just a second. That's right, but I want an example. I just want an example. There we go. Where basically you say what is the column here in this table, which table are we referencing, what's the target table, and then and then what is the name of the column in that table. Okay? So we're going to do that for both of those. You don't have to do the all caps. That's just kind of tradition. If you leave it in lowercase, it works just fine. Okay, so let me test these, and then I'll put them in Slack for you guys. Both worked. Beautiful. Let's toss it in Slack. And cool. Are we going to cover Cascade? We'll cover Cascade at the end. What's up?
Why did we add those last three fields?
These, so these are called constraints. Okay? So every table must have a primary key. I don't actually remember if that's a technical must-have.
You just said we don't need it.
What?
Earlier you said we don't need a unique primary.
No. You need a primary key,
Okay.
but it can be a composite primary key. So right here we're actually defining a composite primary key.
Well, what would that look like in the table? If it even exists?
It is not. It's not actually a field. It is describing the behavior of fields. It's a little difficult to wrap your head around. We're basically telling the table that these two values put together should be unique.
How do you know that it's not a field? Is it because there's no name for it?
Basically because primary key is a keyword. So if you were to try to do a field called primary, like a field called primary key, it would break. It would be like, what are you doing? You can't make a field called this. On that note, actually brings up a good point. If you do want to use a reserved word, like type or int or whatever, now I don't recommend doing it. But if you have to, you can use backticks to tell it to take the text literally. Okay? But I recommend avoiding that.
And what are the last two foreign keys?
These are foreign keys. These enforce the relationship between this table and the other two tables it's referencing. Okay? So this is saying that the employee ID field in this table is referencing the employee table, the ID column in that table. And then organization ID here is referencing the organization table and its ID column.
So you could technically have like references employee, and then instead of ID, like name or something, if you wanted to reference the name.
You could. However, when you're using foreign keys, you almost always want to use the primary key as your target. It's much faster. We're going to get to indexing at the end of class, and I'll explain how that works, and that will explain why it's faster. Okay.
I just having trouble here. Earlier we created a user class, and then I tried to create database, but I cannot have the access.
Right. We're going to cover permissions once we get the data in. So for now, log out, log in as root, and then do that. Yeah. So that was a good question. If you following on the recording, you want to run all these create table statements as root. We will cover. You can grant. You can grant. I really hope the audio has been working. You can grant other users permissions to create tables, but I recommend against it. We're going to cover how to grant permissions in just a couple minutes. Let me fix my headset. All right. So does anyone have questions about creating tables? So, what should we do next? Let's do. I know we're going to do that. Is there anything we need to cover before that? Now there are additional things you can do with primary keys. There is something called cascading, where you can say, oh, hey, if this record is deleted, delete the related record as well. Or don't allow this record to be or don't allow the target record to be deleted if this record exists. Like if I'm still depending on it, don't allow it to be removed. Not going to cover that today because that can get really complicated, but that's called cascading. If you want to look that up on your own time,
That's the keyword that you're looking for, cascade. Okay, so now that we have our tables, now that you know this DDL for defining tables, let's actually write some SQL. Okay? So there are 4 major operations in SQL. They are select, insert, update, and delete. Okay, so now we're getting into SQL. Okay, this is the part that if you're an application developer, this is the part that you really, really, really care about. Okay? Select reads data. Okay? It does not change data in any way, it only reads. Insert puts new data into the table. Update changes existing data. Delete removes data. Okay? No big surprise there. Each of them has their own grammar. Okay, like there's kind of like almost a sentence structure, if you will, that each of them follows, and they are different from one another, so we're going to cover each of those. Normally, when people are teaching things, you start with select, but because we need to get data into our tables, we're going to actually start with insert. Okay, so how does insert work? Again, insert is to add data. You specify the table. You specify the columns you want to insert data into, because you can leave some columns as empty, or some columns can automatically be set. And then you specify the values that you want to put into the table. Okay? So the way that works is you say insert into and then the table name. And then you give the column names. So we're only going to insert into name and phone. And then we're going to insert some values. And then you can insert multiple records at once. And I'm breaking my own rule here, and it's terrible. Okay? James is lucky. We can't forget that. And Bob is evil. Okay? So this is what an insert statement looks like. You have insert into the table name, followed by the columns you want to insert into, surrounded by parentheses, followed by the keyword values, and then for each record that you want to insert, you surround them in parentheses, and you give the data that you want to insert. Now, the data that you're inserting, the order should match your column order. Okay? So if I did something like this, the phone number would be Beej, and you don't want that. Okay? So you want to make sure that your order between columns matches. Now, your column order can be in any order you want, regardless of how you defined it in the table. Okay? So just be aware of that. So in this case, each record is separated by commas. Okay, so this will insert 3 records, and it will actually look like this at the end. Okay? So now if we go ahead and run this, okay, you can see query OK, 3 rows selected, and 3 records were done, no duplicates, no warnings, everything's cool. Okay, so cool, we added data to the database, woo! First data. What's up? Good question. So, and I should have covered that sooner. So the single quotes, the single quote that I have highlighted here in SQL means this is text data versus a keyword or a column or something like that. Okay? So we're inserting the text data Beej, or the text data 555. Okay? So now we've got data in our database. Okay? And now to pull data out, we use select. Does anyone have any questions about insert? Cool. All right, so let's move on to select. We've got data in our table. How do we get it out? The select basically follows this grammar. I just have to show you. Okay. Select basically looks like that. It's very simple. Okay. you say select, and then you say the columns that you want. Then you say from, and then the table that you want to pull data from. Okay? If you say star, it will pull every column, all of the fields, for the table. Okay? And in this case, we're going to pull all of the data out of the table. Okay? In our tiny little test database, that's okay. On a production database for a living, working product, you don't want to select all of the data. You will have a bad time. Okay? We're going to cover how to filter data in just a second, but I don't want to overload you all at once. So if you copy this and you paste this into your database, you'll see the data that we grabbed. Okay? Now you'll notice the ID was set to 1, 2, and 3, but we didn't insert that. That is because we set it to auto-incrementing, just like we mentioned before. Okay? Any questions? Cool. So to get to kind of the interesting stuff, whoa, okay, we're gonna have to go a little bit faster. To get to some of the more interesting things, let's go ahead and put data into our other tables. Crap, I set manager ID to not null, didn't I? All right, whatever. So I'm just gonna paste this into Slack so you guys can copy it because I don't want to take up too much time. Dev, finance, HR, and we're just going to make James manage everything. I didn't set a primary key, but whatever. Okay, so we're going to do that. Or not I didn't set a foreign key, but that's okay. And let's paste it. Whoops. Let's paste this into Slack. And then we're going to what? No? Whoops. So Beej is in dev. James is in dev. Wait, whoa, okay. James is also in finance. And Bob is in HR. Cool. Is James also in HR? Oh, you're right. So James does need to be in HR. No, he manages HR, but he's not in HR. Okay, so whoops, let's paste this into Slack. Okay. All right. So now we have some data in our database. We can select star from employee. Whoops. And we get data. We can select star from organization. And we get data. We can select wait, what the hell? Oh, I ran it twice. Actually, that kind of works out. Because then I can get to show you delete. From LK employee organization. And there we go. Now, so I made a mistake, but that's actually kind of lucky. So you'll notice in organization, we have duplicate records. We have dev, finance, and HR entered twice because copying and pasting is dangerous. Okay? So this is an opportunity to show delete. Okay? If you didn't insert twice, you don't need to do this. But basically, the way delete works is delete from table. Okay? Now, if I just did that, all of the data in the table would be deleted. Okay? So that's bad. But that's where we get into useful things like filters. We can say where is how you filter, ID is greater than 3. Nope, there is no undo. There is no undo in databases. Before you run a query, be very sure of what it's going to do. Find the person next to you, have them check your query, make sure it's right. You don't want to... You guys heard what happened to GitLab, like, what, 4 or 5 months ago? Like, they blew up one of their databases, and their backups weren't working? Yeah. Yeah, don't be that guy. Okay? So I'm going to run that. Select star from organization. Okay, cool. We're good. Okay. Now, what if I wanted to filter on my select? Well, where actually moves into different places. So we can also do where name equals dev. There we go. And as I mentioned before, in this case, star means all columns. You can select out just specific columns. So you can say ID and manager ID. And that'll work too. Any questions about that? Okay, let's get to the interesting part. So, we have, another DDL keyword that you will want to know, describe. Will show you the structure of a table. So if I do describe employee, it will tell me the definition for the table. In nice fancy ASCII art. Okay? So, we have these 3 tables. The tables, via the foreign keys, have their relationships defined, right? But what if I want to pull out the data and have those relationships all put together? How do I do that? There's a keyword called join, okay? It joins data from one table to data from another. Or if you want to get really fancy, you can actually pull data from the same table and kind of duplicate records, but we're not going to do that today. So how does join work? So I'm going to start with star. Generally, you wouldn't want to do star on a join query, because then you're going to get IDs and you don't care about IDs most of the time. Okay? So you're going to start with the table that you're filtering on. Right? So in this case, if I want all employees who are developers, right, I'm filtering on the organization. Okay? So I'm going to start with that table. You don't have to, but it's what's considered good form. So I'm going to start with the organization, again, because that's where I'm filtering from. And I'm going to say, Now, you'll notice, if we look at employee and organization, they both have a column called name. So if I were to just select name, it wouldn't know which table to pull it from, because it would actually give me an error saying column name is ambiguous, because it doesn't know where it should come from. So what you can do is you can do like organization.name, right? But that's really, really, really long. So anytime you have a table, you can alias it. Okay? And people will sometimes use single letter aliases. But for purposes of keeping things simple, I'm actually going to use the full name. So you can say we're organization.name equals dev. Okay? So this will give me the dev organization. Right? There we go. Okay? So we start with that. And we have our filter working properly. Now, if we want to join it to the employee data, how many tables are involved in that? Yeah, so 2 more. Yes. So I need to do 2 joins. First, I need to join this data to this data. And then I need to join this data to this data. Okay? So first, let's do this part, and we'll do a select, and you'll see how that works. So the keyword is join. And you say the table that you want to join to. So I'm going to say LK employee organization. And then the database needs to know what logic to use, what criteria, what constraints to use to connect a record from one table to a record from another table. Okay? Now, you can have one record from here join multiple records from here. That's okay. That's actually what we want to do here. Okay? So we can do LK employee organization dot organization ID, equals organization.id. And that will be our criteria to take a record from here and match it to one here. Okay? Oh, sorry. I missed a word. Before that, you have to say on. On is the key word for that filtering. Okay? So now if we toss that in there, you'll see we have the ID, name, and manager ID from organization. And we have the employee ID and the organization ID from our linking table. And you'll notice that the ID in our organization table always matches the organization ID because that was our constraint. Okay? Questions about that? Good. All right. So now that you know how join works, can anyone tell me how to get from this table to this table? And then what? Yep. Say it again, I'm sorry. So that would actually work, because employee ID is unique, but for purposes of being explicit, we want to do this. But that would work. So if we do this, womp. There we go. Okay. Now that's a mess to read, right? So now we can make but good job on the join. That's exactly what we want. Okay, because Beej and James are the people in the organization with the name dev. Okay. So now we don't want all these columns. We only want some columns. So we can say organization.name, and we can say employee.name, and we can say employee.phone. If we do that, come on. There we go. Now we get nice clean data. Now, name here is a little ambiguous, so we can actually fix that too. Just like how you could alias table names, you can also alias columns. So you can say organization name as org name. You can say employee name as EMP name. And then if we do our select, you'll see that the field headers change. So nice things to make your query nice and clean and easily read. Okay? So let's go ahead and toss this into Slack so people have it as a reference. Wow, right on time. Search. So filtering is technically how you search. If you want to do a fuzzy search, you can do like, and then you can use a percentage sign as a wildcard. And this would give us the same results because there's no other organization that ends in EV. But yeah, that is the closest thing to a search. If you want to do fuzzy searching, like it'll account for maybe there's a typo or something, that requires a lot more logic. I think the common method is like the Lichtenstein method or something like that. You'd want to Google it. You would just want to Google fuzzy matching SQL. So we covered insert, we covered select, we covered delete, we covered filtering with where, we covered joins. We have not covered update, so let's do that real quick. Let's say that James changed his phone number. Okay, we could do update the employee table, and then we can set phone equal to new value. Let's do 111. And now, actually, this is sorry. When I write update statements, I actually do the set last. Same with delete statements. I actually don't put the table name in when I'm writing a delete statement until I'm finished, because if I accidentally hit enter and it doesn't have a filter on it, that would be bad. Because if you just did this, it would set all employees' phone numbers to 111. So when I do an update or a delete, I start with update where name equal James, and then I do set phone equal 111. Okay? And that way it's just kind of a little thing where it's just a safeguard. Okay? So now if I do that, and then I select star from employee again, you can see James' phone number is now 111. Yay! Oh man. Okay. So, any questions about update? Can I like move it up here? No, the order does matter. It must be in this order. I kind of wish that they had the where first, because that would make sense, but that is not how SQL is defined. Good question, and I do wish it was that way, but it's not. I apologize that we took a little longer than I expected. I was going to walk through like the logic around creating an application to pull out of a database, but instead I'm just going to write it very quickly and show you, because we are effectively out of time. So, hey, what do you know? I have a project already. This is perfect. So if you downloaded Python, I'll put this project on GitHub so you can reference it later if you want to, but we don't have the time where I can cover how to do everything. So, give me just, holy crap. Yeah, I know. Yes. Crap. Oh, really? Of course it did. Really? Well, that's a bug. Okay. Well, crap. That made my example much more complicated. Well, that sucks. Okay. What's that? Sorry? Right. So, basically, this requirements file is a common way to import or to download dependencies. So, like the MySQL connector for Python is not a default part of every program. So, I was going to download it, import it, and then I'm just going to grab an example from some code I've already written, because of course I don't have it open, do I? Of course I don't. Okay. Give me just a sec. I'm basically just going to copy some code I already wrote, because there's no point in figuring out everything already. Holy crap, this is a mess. I'm embarrassed because my code is disgusting. That's not actually what I want. I want the SQL processor. And of course I'm using that's right, I'm not using the default. Well, that sucks. Sorry, guys. I was not as prepared for this as I thought I was. Hey, there we go. Hey, look! We can just do that. Check that out. It's root. Oh, I didn't cover permissions. All right, we'll have to do that very quickly at the end. I'm pretty sure it's not going to work, but whatever. Let's get rid of that. We don't need that. And then for ID, what is it? ID name phone. Pretty sure it's going to fail because yeah, it can't find MySQL. Killing me. Okay, so what we're going to do is get fancy for just a second. And sorry guys, I thought that just installing that would work. And what's really strange is that, oh, hey, I have an idea. It's the same thing. It is the same exact thing, so why isn't it working? Well, that super sucks. Okay, well, let's just download the connector real quick. Or no, I don't actually want the, I want the zip. Oh, they only have the MSI installer. Well, I promised that would work. Sorry guys, we don't have enough time for me to actually go through and show. Well, actually, maybe we do. Hold up. Well, let's do, no, I'm using Python 3. Let's just say source code. RPM package. Really? Platform independent. Compressed, there we go, that's what I want. Alright, so we got that. And we got that. Site packages. Is this what I want? I think this is what I want. Let's actually no. Yeah. Okay. CD. No, /lib. Come on. Python setup.py. What? Python setup.py. There we go. Of course. Setup.py install. Hey! Okay, there we go. Cool. We're good. And now, if we run it, invalid format specifier, of course. Oh, we don't need. That makes sense. And then there we go. Hey, you can see right here. Sorry that took so long. Well, hopefully you can see. It's kind of tiny text. But I will also put this on. I will clean up this project so that it works, and I'll put this on GitHub and I'll send a link in Slack. So basically, with this is we're importing the MySQL connector, which is all of the code that tells Python how to work with MySQL, because that's made by people a lot smarter than all of us. and then we say, hey, go ahead and connect to the database. Give it the username, the password, and the database we want to, the schema we want to connect to. Usually, you'd actually want to do this in a configuration file and not have the password in your source code. But again, we're just trying to do something quickly. Usually, when you're working with databases, you get a cursor, which is basically an object related to this to one query at a time, and that will fetch you your data as you need it. And then we define our query. In this case, we're saying, oh, hey, we want to select everything from the employee table. We tell the cursor, go ahead and run this query. And then we can loop through each result in the cursor. And we can basically pull each field into its own variable. And then we just print it to the screen. However, we must make sure that when you're working with databases from applications that once you are finished doing your work, you should close your cursor and you should close your database connection. Okay. Couple of quick things. I'm gonna we didn't cover user permissions. If you wanted to give your except I can't type. What? Oh, it's user. Holy crap. Okay, well. Wow, that's gross. Of course. Why are there so many? Well, my username. Okay. Okay, so that's what I called it. So if you wanted to grant, you can do like select, insert, update on your database name to, and then the username. So in this case, my username at localhost. Whoops. Whoop. Except I'm in another schema, so I have to do... Oh. And that will grant select, insert, and update privileges on everything within the DB class schema to the my username user. And then we're also going to cover indexes. I'm going to run through it really quickly. Indexes are basically, so you have your table data, right? But that's all in a certain order. So if you're looking for like name, right, but the order is based on the primary key, how does it find name? It's not going to search through the whole table. That's just a mess. So what you can do is you can define what's called an index. An index is basically a separate area of storage where I can say, if I want to index on name, I can just pull name into an index, and then it will go for everything where there's Beej, and it'll say, okay, that's at primary key 1. For James, he's at primary key 2. Actually, it would go Beej, then Bob at 3, and then James, because it would go in alphabetical order. Now, the reason that the alphabetical order matters is in computing, when things are sorted, you can search it really fast, because there's search algorithms built for sorting. So when you create an index, this is basic. It's a little more complicated than this, but this is basically what happens is it takes all the values, stores them in order, and then points to their primary key, so that it can search based on the value, find it, and then go to the primary key, pull the record, and there you go. For indexes, it's really simple. If you just look up in the MySQL spec, it will tell you how to do the indexes. I'm pretty sure it's just index, name of the index, and then the columns in the index, and the type of index. But we are 10 minutes over time. I apologize. So if you have any other questions, just ask on the Slack channel. If you have any questions for me, you can message me on Kakao. It should be on the meetup page. Or I would prefer Slack. I would prefer that you ask in the broader channel so that if other people have the same question, they can see the answers. But thank you for coming, everyone. I hope you enjoyed. Again, check out Facebook and or Meetup for more of our events. And hope you enjoyed. If you have any feedback, talk to me afterwards. Thanks.